I'm Griffin Ziegler, and this is my partner Ashton, and we will be presenting over an analysis of the SQL programming language. So this presentation will cover an introduction. Next, we'll go over the history of SQL. Then we'll give you a live demo of how to set up, execute, and build programs with SQL. Next, we'll be going over the basic features. Then we'll be creating our own program to implement some of the basic features of SQL. Then we're going to evaluate SQL based on a few ratings, which are reliability, writability, and readability. And then finally, we're going to reflect on the process that we went through with learning a new language, and we're going to share some of our experiences and what are the benefits and drawbacks that we experience learning SQL. So the goal of this project was to explore an unfamiliar but popular language. SQL is still very relevant, and it's being used by a lot of popular companies like Netflix, Microsoft, Facebook. We're going to be using Oracle as our program to implement SQL, and we're also going to be covering our observations and analysis of how SQL works. So before the 1970s, database systems were a newer area of research and development in the computer science field, and the primary database models at the time were hierarchical and network database models, and these were less efficient because every time you had to update their databases, you had to write a program, and you would have to rewrite that program every time you wanted to make changes to these databases. And so Edgar Frank Codd in 1970 published a paper which basically created the relational model, which was a lot more efficient because it allowed you to separate the logical data structures, which are the data tables, views, and indexes from their physical storage structures. So unlike the database models before the 1970s, the relational model allowed database administrators to physically manage data storage without affecting access to the data's logical structure. Edgar Frank Codd is referred to as the forefather of SQL, but it was really Chamberlain and Boyce, two workers at IBM, or two computer scientists at IBM, who worked on System R, which tackled working with Codd's relational model. And so Chamberlain and Boyce had to come up with their own language, Square, specifying queries as relational expressions using Codd's ideas. Their language Square was a lot more efficient and user-friendly, and it also made SQL, well, it would make SQL more accessible in the future because it wasn't based on understanding, having like a complicated understanding of mathematics and computer programming. So their ideas were that their language that they were developing would be accessible for everybody. Eventually, Square is modified to fit syntactical English, and it's called SQL, and eventually that's shortened to SQL. And later on, there's many standards published to SQL. As you can see here, the American National Standards Institute published the first SQL standard, which basically it basically set the foundation for SQL standards and which were updates to SQL, and SQL 86 gets revised in 1992, and SQL 2 becomes the foundation, and then later on SQL 1999 becomes SQL 3 because it changes accessibility, and the updates following are just quality of life updates. Overall, SQL holds up pretty well nowadays, despite cloud computing. Although cloud computing is starting to surpass SQL in the fields of big data management, which is a lot of what these big companies are doing, SQL is still holding up on smaller scale operations. Google taught one of its databases to read and use SQL, and found that SQL was just as efficient, and they decided to create their own SQL standard. So you can find SQL everywhere, and it's still very relevant and popular today.
In this tutorial section, I will go over the installation of Oracle database using the Express Edition, and then I will go over table creation, data insertion, and data retrieval. So first off, starting off with installing Oracle, you can just search Oracle Express Edition in Google, and it's free. You just visit the site, download it. I ran into a few issues installing this because I have a processor with a bunch of cores. So you might run into an issue whenever you're installing and it won't install. You'll run into just a bunch of problems. So I had to actually go in some of the program files, and I edited a DBC file and inserted some text that was saying basically, hey, I only want to use 2 cores. So your mileage may vary depending on what kind of processor you have. And so that just kind of, and then something else I wanted to show, if you go into the services app and if you go all the way down to where Oracle is, and that's where the O's are. These over here, I set them to manual on startup. I would recommend that you have these set to manual. They're usually come with automatic. This is because there's a bunch of uh, uh, memory that's taken up, and you could check in Task Manager. So I'd recommend doing this, and then whenever you're done, you can stop each thing. So we start off with a relational schema diagram. This is usually derived from an entity relationship diagram or an enhanced entity relationship diagram. And these tables right here, employee, department, department locations, these all have attributes. Employee has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It has 11 attributes here. And you can see these arrows are the foreign keys. So these are referencing an attribute, and they can reference attributes from other tables. And so creating a table, we will create a company database. I actually already have a file that I like to keep everything on my C drive. I have a temp folder, and then here is the database that I will be working with right here. To create a table, you start off with the create table and then the table name and then the body within the parentheses. You have a semicolon over here. You have your attribute space between. It could be some spaces or just a tab. It doesn't really matter. And then a comma between each attribute you add. And I have a constraint at the table level. You can actually have the constraint over here. It's just at the table level. It makes it look a lot neater. So let's create the project table over here. I have create table project, and then I have the attributes. You could see P name, P number, P location, and then the data types along with the size. And so some data types don't require size, like the date data type. We'll get into that. And so now we're going to get into adding foreign keys. But whenever you're running a database and SQL Plus, every time you run it, you should include the drop table and then the table name. So, we would have a drop table project and then cascade constraints, because every time that you add a foreign key, it will try to reference a primary key. And essentially, whenever you're recreating a database, it'll throw errors and won't let you do it. So you should always include at the top of your file drop table and then table name and then the cascade constraints. And I will open up this file right here. You can actually see where I created the project table, and then you can see drop table project cascade contains constraints because I have the foreign keys associated. So that is creating a table, and then inserting data. You use the insert keyword into the table name and then values. And so the values that you insert have to match with the data type. And so if it's a string, it should be between single quotes. If it's a number, for example, then it should be not between quotes. And so an example is inserting this tuple into the project. We have product X, which is a varchar2 data type, and then you have a number, and then another string and a number. And so whenever we're talking about data retrieval, so whenever you're trying to look for data mathematically in SQL, a Cartesian product between two tables will result in a table that has the attributes equal to both the tables, both of the tables attributes combined. So, and then the tuples were equal to both of the tables tuples multiplied together. And so, we're going to cover the unary relational operations select from where, and then the binary relational operations, the Cartesian product, and then join. We'll actually only get to Cartesian product, and then for set theory operations minus. This is these illustrations over here are really helpful. This is kind of what the minus, and this is, if you're familiar with set theory and mathematics, this is kind of what we're dealing with. So we can use a data retrieval using the describe. This will basically show if I did describe project, let's see, if I did a describe project, and if I opened up SQL over here, let's find where the O's are. Oracle, SQL Plus, and I'm gonna do, and you can use this if you're the person who installed it. If I do describe project, ooh, don't need this right here. You can see that we get the table layout right there. And then we can do the further unary relational operations. And so we can do select this attribute from project and run this, and you can get the project number, which again, we were looking at before. Here's the product number. So you can kind of see this mirrors that right there. And then we can also use the star symbol to actually select everything. So this will bring up a bunch of data, which is kind of unreadable, which leads us further into this over here, where our data retrieval, so we have select from, and then the table name, and then the table name. This is using the Cartesian product. And so we can try running this command, and this will basically combine our two tables, realize how big this table is right here. So we can further filter by using the where clause. And so essentially, if we run this right here, you can see that we got a lot more filtered out data. And we can actually run this command right here. Let me get this. And I'm going to do, I'll have to manually type this in. I will do select there from employee, and this is the Cartesian product, and then d number is equal to dnum, and I'm going to insert a keyword distinct in here, and this will flesh out a bunch of the dupes that were created, because these two tables are being combined together, so it's a huge table. And then we have data retrieval using set theory operations, and in this example, I use the minus. So these, you can use a, if you have a, if you're trying to retrieve the name of all the employees who have no dependents. So if we go back to our relational scheme over here, actually stay on here. So we're looking for all the employees who don't have a dependent, and you can see that a dependent has a an employee social security that they're associated with. So we can find, this guy's social security is over here. And so this guy right here is going to be the supervisor employee over the dependent. We can run this command, and this will give us all the name of all the employees who have no dependents. And this really is a useful tool whenever you're trying to filter, retrieve data and trying to not get a huge table view of just garbage on your screen. On this basic features section, I will cover the paradigm, data types, and control flow of Oracle. The SQL is a declarative programming language and the program language paradigm with procedural elements. And the imperative languages follow operations to complete the program, and the order of the code actually matters. Procedural programming is where the program executes commands with unspecified instructions, while declarative language means that the ordering of the lines of code actually it matters. So SQL requires an interpreter rather than compiling a code. And for this, I will be covering the PL SQL, and that is Oracle's extension to SQL. It stands for procedural language extension to the structured query language. So PL SQL adds procedural elements to SQL to add more functionality in the database. Whenever we're talking about control flow, using PL SQL allows for more capabilities that are not included in SQL alone. And it handles variable subprograms, stored procedures, but it does add more complexity compared to SQL because you're not just in the command line. I won't actually be going through any I'll just be looking over some code. I have T-SQL over here. That is Microsoft's version, but we won't be covering that. And due to time constraints, I will have to not go over each of these data types, but some important ones is the varchar2 size. You can see that it's a variable length data type, and the size. So you can have a varchar size or varchar2 size 20. You can have a character string of 20 characters max, and then compared to like a char data type, if you have a size of 3 but only use 1, then those two characters are padded to the right, and so that would lead to like wasted memory. So most of the time you're going to be using varchar 2 since it's a dynamic, but you don't want to waste in memory. And so then another important one is date, where you have like 28 June, GUN, and then the year like 2023. Here's just an example table showing some of the data types. That realize that there's not a primary key for this table, and that's just for sake of brevity. And then onto the control flow. On the if statement. So whenever we're talking about control flow, it's the order in which things get executed. So like where a loop can repeat in enclosed lines of code a certain amount of times, and add if else statements, it can jump over those lines of code. So for this if you have the if then control statement, the condition, if it's true, executes in the body of these, and then until it execute these, then it's the indef control statement. Over here, it's the if then else control statement. And essentially, if the condition is false, you're going to be running the else. If the condition is true, you're going to be running what's in here. And then you have the indef control statement. You have the while loop. very similar to what is seen in programs like C++, where a while loop can be run on you want to when you don't know how long a program is supposed to run for, the condition will until the condition is not true. For n loop, this is actually a pretty complicated one where count will take on the value of the initial, the n initial, and then it'll go to n final. And so it'll keep looping through this body of code until it goes back up to the control statement, and the n initial will be greater than the n final. And so then we end the loop. A loop is a useful because it basically will execute the statements within the body until that's whenever you enter in a exit control statement, because the clause when for the condition will basically, if you put that inside of a loop, and that's where you mostly find these exit control statements, is that the condition, whenever it's met, it'll exit the loop. Otherwise, the loop will run at least once. That's what it makes it different from the while over here. You want it to run at least once. This condition might be false, but this one will always run at least once, and you might hit the condition over here and it might end.
Next, I'm going to be going over expressions. In SQL, expressions combine one or more values, operators, and SQL functions. SQL expressions have the same data type as their components. They can be used in select statements, clauses, insert statements, and update statements. There are a lot of different types of expressions in SQL, but for time's sake, I'm just going to go over two. First, we have a simple expression which specifies a column, pseudo-column, constant, sequence number, or null. As you can see in this example, we are specifying null. The next example is a compound expression, which combines at least two expressions, and in SQL, compound expressions have limitations on the combinations of built-in functions that they accept. Subprograms in SQL are executed using PL SQL blocks. There are two types of subprograms in SQL, which are procedures and functions. And subprograms in SQL have three different parts, which are the declarative, the executable, and exception handling. In SQL, we refer to objects as object. So object refers to the name of an object. Schema is the schema that contains an object. This qualifier allows the user to reference other objects with privileged access. So when you refer to objects in other schemas, you have to have granted privilege access. With the omission of schema, Oracle assumes that the user is referring to an object in their own schema. The part identifier allows the user to reference part of a schema object. So when you are working with statements such as the one below, Oracle will take these certain steps to resolve the name department, as in this example. Firstly, it will attempt to locate the object in the namespace and the user schema containing tables, views, and private synonyms. If the object is private, Oracle locates this object by its synonym. Next, Oracle will attempt to perform the statement on the object if it is located in the namespace. In this example, Oracle attempts to add the row of data to department. An error is returned if the object is not of the correct data type. Here, department must be a table, view, or a private synonym resolving to a table or a view. If the object is a sequence, an error is returned. Next, Oracle will search the namespace containing public synonyms if the object is not located in any namespace that it has already searched. If it locates the object in another namespace, it will attempt to perform the statement on the object, and if the object isn't the correct type for the statement, an error is returned. You cannot create an object having the same name as the synonym in the same schema if a public synonym has any dependent tables or user-defined types. Also, another limitation to consider is that if a synonym does not have any dependent tables or user-defined types, you can create an object with the same name in the same schema as the dependent objects. Finally, we have exception handling. So when an error occurs in SQL queries, SQL uses try-catch exception handling. The try-catch construct handles exceptions in the server. The try block contains all statements that need to be executed, and the code in the catch blocks is executed if failure or an error occurs. SQL also uses error functions, which we see in this example. We see some of these functions being used. Firstly, there's error line, which returns the line number where the error occurred, error message, which returns the error's description. The next function, error procedure, returns the name of the stored procedure or trigger when the error occurred, where the error occurred. This function will return null if there's no procedure or trigger. Error number returns the error number that has occurred. Error severity returns the error severity level. Error state returns the error's state number.
This section of evaluation, we've covered so far the control structures, data types, the syntax design, and the abstraction and the type checking and the expressivity, exception handling and restricted aliasing for PL SQL. And as you've seen, it's really simple because it was designed around the English language, like the unary operational like select and from, and then the and or operator, logical operators. So it's very easy to understand, and anyone who's getting into it should have not a hard time to understand what's going on in SQL Plus. PL SQL it does get a little bit more complex, but it offers more of those constructs to be grouped together into a single block and executed as a unit, which would allow for, one or more SQL statements and variable declarations and assignment statements and procedural control statements like if, then, and else, and then loop and loops, and then for exception handling. There was this a resource by Keith Gebraleski. I hope I'm saying that name right, but he has some tips to follow to help with formatting SQL statements for readability. And I won't go over all these, but follow some semblance of normalization. So try to keep everything organized, and which I really try to do whenever I'm and like whenever you're putting in a foreign key, try to make that the identifiers are easily understood. But you have things like name your tables, plural nouns, which from the previous examples I did not do, but so a bunch of these tips over here will help for improving the readability and writability of SQL and PL SQL. On this reflection of our experiences of studying SQL as a new language and learning some of PL SQL, it was fun, educational, and it again is another tool on the belt whenever we're learning a new language. It can be frustrating, learning a new language, but knowing that it's still relevant and very much used nowadays is assuring. And there is actually a few frustrations that I had about finding resources, but I actually won't deny that I found a really Oracle, I've just put Oracle Docs Programmer's Guide, and Oracle has a guide, and it's very thorough, and they use a SQL Plus, and they use Oracle SQL. So I would recommend visiting this if you have any questions that you can't find on the internet, which normally I found a lot of my answers on the internet, but for the next time, whenever we're implementing SQL, we agree that we should show more of its features. The 20 minutes was hard to get everything covered, and I believe we're running a little over time, but and then, utilizing different schema designs for those next implementations. And you can get as, creative, especially with the enhanced entity relationship diagrams. You can have a lot of fun with creating a database of your own, and so it was really a nice learning about SQL and as a programming language. And here are the references. And thank you for watching our presentation.